All right. So, today's the handout already posted. I think first item is slides, and second one is a chapter of the book that I wrote about database security. I believe this is it, right? So you can enjoy reading some of the security issues about the chapter that I wrote. This is encrypting databases. Okay, it has some others. Let's see. So this is the slide that we are going to cover today, which is here. And I need to set up the slide show. Therefore, it'll be presented on this space. Okay. So what we have done so far, we covered the course materials so fast. I didn't cover anything tedious, anything not really needed in many cases. Some of the theories are very olden days theory. Database is not anymore rigid, formal. It's not anymore rigid technologies. What I mean by that is some of the rules sets defined, and all other database needs to follow that rules. Unless otherwise, it is not to be saved. It is not to be served at all. That type of things is olden theory, but now database is not just a database that we keep in rigid format, but we call any repository a database. So any web page that is also web database. Anything that is not following any formal structure, that is also called the database. Even multimedia, then we call that if multimedia is stored in a database, then we call that multimedia database. Some of the publications, books, journals, periodicals, newspaper, anything, it could be also stored in a database. Therefore, there is no formal structure at all. Knowing that, traditional theories and formalism that discussed in database communities are not really as significant as it was like some decades ago. So if you buy database textbooks, they still cover so many chapters that old things. If you like theories, you may like it. If you do not like theories, then it is useless. Therefore, I didn't cover that. Only something that you really need when you implement something in your database. One of those things is encryption. Data stored in your database, what if it is compromised? Then you lose your data. You lose your value. Therefore, we want to encrypt some of the content. So even if data is compromised, that person may not be able to get that value immediately. It may be decrypted. It may be decrypted if it takes decades. Worst case maybe a million years, but best case immediately. But anyway, we can delay the data leakages if we apply strong encryption algorithms. That's what we want to learn today. So we'll look at database encryption granularity. Are we going to encrypt the entire database? Are we going to encrypt the entire table? Or are we going to encrypt a particular column or particular row, whatever? And Oracle encryption is one of the best encryption technologies in database community. If you are interested in, if you need to do, you may take a look at some of encryption technologies provided by Oracle. What that means is that the encryption technology that we could do in MySQL is very, very, very limited. Limits in encryption technology basically caused from the algorithms. How many encryption algorithms provided by MySQL? Right now, very, very limited. And today we'll look at only one, advanced encryption AES, okay, which is not bad, which is a lot better than DAS code. But so that is available. And also key management. What if you, well, when you encrypt, then there's a not really key, but there's some of the phrase that you enter, right? Then that phrase is somehow encrypted, and the key may not be tampered. But anyway, we have to remember that in order to decrypt it, right? What if we use different keys for a particular column of particular tables? How many columns are available in your database? Maybe 100 columns you have, because you have tens of tables you defined, right? Then it's not, I mean, that key management is another issue. So how can we deal with it? Those are all the topics that we have to consider. But today we'll look at encryption and decryption more intensively. Encryption. This is some of the, I think you've seen this so many times. Information security from bottom to top. So we're forced to consider something about authentications. So authentication is needed almost all the information that we have, because the size of a bottom, that is the wide, right? That is huge. So most of the information amount needs to be accessed by authentications. So authentication is needed. So what authentication needs to check is to who you are, right? Who is it? And if we want to tight a little harder on our information or database, then authorizations. once user comes in my system, still user needs to be checked for authorization, whether that person is allowed to read, write, or execute any specific data item of any specific table or database. So very, very sophisticated access needs to be controlled. That is authorizations. So what it wants to verify is to verify who can do what, right? Another thing is the encryption. So that is the topic that we are going to cover. Even if somebody can access any specific data item, if we hide the value of that data item, then that person may not get the meaning of that data, right? No values, because that person cannot understand it. So who can see it? Only those who are authorized, those who have the key. One last thing, which is on top of the pyramid, is the audit. Let's say we managed our security according to that hierarchies very systematically and efficiently, from authentication, authorization to encryption. Still somebody successfully attack and get the data. Then finally what we need to do is, if we can audit it so that we can trace back who did what, at least, then we can at least detect the cause of that attack, detect the point of vulnerabilities of our system, and therefore we may be able to enhance our security management. So audit is final step that we need to do. In order to audit your database, keep log files always. In database, there is a special protocol implemented and enforced. That protocol is called log ahead protocol. Log ahead protocol. What that means is that in order to execute something, if somebody requested to some actions, so that user may pose SQL statements. Before that SQL statement is executed, that SQL statement itself needs to be logged in the separate files. Therefore, we need to know who wants to do. So it's successfully that executed. Later, oh, he's the attacker. Then we need to see what he did, right? So log ahead protocol is very, very important, rather than log later protocol. You see the difference, right? Log ahead, then we see his intent at least, and then anything after that. If we have a log later protocol, then he did his action, but immediately system crashed. Then we do not know what he did, right? Because his statement has been executed, but before we logged it, system crashed. Then we don't know what he tried to do. But if we have a log ahead protocol, then we already saved his statements, and then system crashed. Then at least we know, oh, this guy tried to do this. Oh, thank God, my system crashed, so it didn't take place. Best scenario, right? Worst scenario? Logged, an action taken. But still we know, oh, this guy did something wrong. There's audit, okay? Database encryption. The schema, relation schema, which is in theory, alls here, alls of I, that is a relation I to I, and then there is attributes, list of attributes. This is the schema, right? Relation schema. If it is not encrypted, then they are all in plain text. That's what we practiced so far, right? That should be converted to another form, Ri's of K, in the schema, and then there is some of other encrypted formats. From plain text A, I1 to some of the encrypted cipher formats. That is the encryptions. So in other words, if we have employee ID, name, salary, bonus, then let's say, yeah, encrypted. I think everything is encrypted in this case. Then we do not know everything encrypted. Even column names encrypted, right? So this is the key, this is the counter, and this is EID. X EID is Z, and X NAME, X and Y in between, and Z S Z Y between, and there is a salary and bonus value for that. So this is E111, then EX111, all somehow I made this to get some hint, right? Rather than Adam, then we have X Adam. Rather than Brown, Box Round, Chris 2, yeah, and Danny 2, Danixony, things like that. But anyway, that is the encryption. Encryption granules. Could it be encrypted entire database or entire table, row, column, table field. What happened? Okay. MySQL. So with this in mind, now we need to consider MySQL. So typically column level encryption is available. So we can pick one column. If it is a salary, then entire salary can be encrypted. And also optional. If you do not want to encrypt, you don't need to. But encryption is enabled. That's what we say. How we can enable it? That's what we want to do, right? It's not automatic. We have to do something. First of all, we have to include a specific algorithm. In this case, AES, encryption algorithm. Okay. If we have an AES encryption algorithm, then when we want to decrypt, then we need to have also corresponding algorithms for decryption, which is AES underscore decrypt. That is on the next slide. So AES encrypt, that is a function. That function takes two items, data and key. Actually, it's not really key that's used in the encryption, but phrase that we know. Only we know this. By knowing this, we may decrypt it. By providing this algorithm can encrypt it. So you can simply think, oh, this is the key. Fine. Value, that is a value. Okay. If we want to decrypt it, then, for example, if this algorithm is applied to a specific column called salary, then when you decrypt, then we need to bring that salary rather than data, that column name, comma, and then the same key. Okay. So this is, in this case, this is a symmetric key. You know that, right? I think you've learned. Symmetric key and asymmetric keys. In this case, it's symmetric keys. The key that we provided to encrypt, the very same key can be used for decrypt. Like your home key, or if you have a car, then your car key, right? Almost all the keys that we use daily basis, they're all symmetric keys. The same key that you can lock, you can also unlock. Asymmetric keys, if you lock part of the key, then complement of that key should be used for decrypt, vice versa. There's asymmetric keys. Asymmetric keys are not really popular in physical security. I don't really see any lock and unlock using asymmetric keys in physical world. Anyone have seen? No, right? Here in database, same thing, but you can, because this is a database, it's human-made, man-made technologies, so we can improve this. So asymmetric key may be able to improve the encryption technologies in database. Table level encryption is also available when you create. Look here. Create table name, and list of attribute and attribute type pairs. And before you put semicolon to end, you should say encryption equals Y. Encryption yes. If you want to do it after you created, then you should do alter table T1 encryption equals Y. We're not going to practice this table level, but attribute levels, column levels. What is missing? So if salary is sensitive, then we encrypt it. Encrypted data to be inserted into the field. Remember that size of a salary it's not really big size, right? Anybody on 20 byte long salaries? What is a 20 byte long? No one on that much money. Even Bill Gates or anybody's. Elon Musk.
I'm sorry.
Yeah. No one on that much money. But encryption, if you encrypt it, let's say 200,000, 200K salaries. Wow, that's wonderful, right? So how many digits? 200,000, then it's only six. Therefore, we call that 6 figures, right? 6 figures, 6 bytes. But encrypted cipher is a lot longer than that. 32 bytes long or 64 bytes long. Very low, very long. But I want you to think, when you first create a database with attribute and attribute type, then varchar 10, then that is 10 bytes long. Varchar integer, then usually 4 bytes, 8 bytes, right? Long integer, then 16 bytes. Depending upon attribute type, database allocates different size of columns. But when you do encryption, then size will overflow. Usually, the encrypted version is overflow. My fake encryption here, this is also longer than this, right? Salary is 50,000. Here what? Q50000. This is a little bigger, right? But actually, in reality, it is much bigger than that. So we have to do something. In other words, the size of int, when you say integer here, salary, that is much, much smaller than size of cipher. So we have to modify. Before we modify the size of that column, before we encrypt it. That is the key. If you simply encrypt it, then you have an error, because your database is not ready to store encrypted cipher data, because the encrypted cipher data is usually longer than actual plain text data. So we have to modify the type to binary, var binary, variable binary, whoop, very large object in binary. So what we need to do is this: alter table. If you want to encrypt the salary, then alter table, faculty, modify column salary, var binary 16 or binary 16, whatever. After this, we have to encrypt it. So next thing that we have to consider is, okay, we encrypted the data. Safe. It is not known easily. Fine so far. What if you really want it? To yourself, you have to read it, right? Legally you have to read it. Then we need to have somehow decrypt algorithms. So AES decrypt function returns an object array. That returns an object array. I want you to see here, object array. This is an object. It's not yet plain text. Object array is not readable. Therefore, what we need to do, see here, if you see these statements, AES underscore decrypt with the salary and key, this itself within the parentheses, that is the decryption. Outcome of this decryption is not something readable, but that is object array. That object array needs to be, is not readable, therefore you have to cast it to some characters. If you cast the type, if you convert the type by casting into another type that we can read, there is a character type, then we can see it. Therefore, we put here cast. After we do AES decrypt, then we have to cast. In that way, we can see it. So in general, encryption, so that is a real hands-on. Let's see if we do real hands-on. We come back. Oh, what happens? Encrypted, right?
You have to cast it to see it.
Our monitor is off. Give me 1 sec. Exit and restart. I think that screen completely turned off, right? Oh, now it's coming up. Come on.
I want to check this one from long time ago. Can we go and check it?
Let me plug this into another computer, see how it goes. I think there is the screen issue. Is it somewhere here? display. I do not know. We didn't do anything.
No, it got decrypted.
So
Decrypted.
Well, you see the ones we have left.
This media domain. Can you try to connect different laptops?
I tried two different laptops.
One question. You connected through Thunderbolt?
No. HDMI.
HDMI?
Yeah.
Yeah,
Or you can use yours if you. Yeah, you can. Third ones. Okay.
This.
Put this. Lights is off. Right? Jamal, you can take care of it.
Let's try my laptop.
No, it's not about laptop.
Maybe the wire is loose. If you can restart the device, restart it.
That device? Maybe
Yeah.
can we
It's like HDMI.
can we restart that?
Is-
Reboot?
Reboot.
Is there a switch? It should be switches.
Transmission is okay.
Power switch.
Yeah.
Oh yeah, that is power. I think it was a hit up. Maybe.
Let's see.
Either sender side or receiver side, right? This the other one works, not that one.
This one.
Yeah, that's.
It's gonna take some time.
So now we're looking at the sender side. I think receiver side may be okay, right? It's because one
Any of them
monitor,
should be okay.
one monitor is okay.
Bro,
I think there's some problem with the transmission.
You
'cause
know-
when
you know-
you're connecting that, your like screen's not transmitting to that screen because you can still see this screen.
yeah,
So
no,
it should be blank when you're.
okay. When the HDMI live, you're right. It's blocked my screen as a display, but not all of the laptops, because most of them is duplex. You can do it both.
No, but my
But this
laptop-
one, there is a power for this one or no? The hub,
Oh, it's
the main hub.
it's restarting. It's gonna take some time because.
Yeah, I don't have any green lights.
Yeah, it will take
Previously,
some time. It's-
I had a green light here.
Okay.
Yeah, but.
I will track this.
Oh, now it
Actually,
is coming out. It is
yeah,
coming
yeah,
out.
It's
It is coming out.
restarting.
Yeah, I have green lights. So try your
Try my laptop.
your laptop.
Okay. Try my laptop. Bismillah. Yeah. You see, it's blocked. No. Bismillah. So you can restart this one, the main, this one.
Yeah.
Pull up the electricity and put it back.
Yeah, it's.
Did you restart it?
It started transmitting. Let's wait. But it's still red. It should be green.
Try on your
Try now?
laptop.
It's connected. Nothing. No, last one, restart this one. Track it, restart it.
This device?
Yeah, this
That
device.
that comes here. I think. Which line is it?
Wait.
This,
I've already
this.
restarted that one.
This one.
Take it off for 5 seconds.
Someone.
This.
All over three goes there, right? You can plug out and in all over those.
Yeah, it's disconnected.
This one.
Put it back.
Marked.
System starting up. It's gonna need time. Like 2 minutes. You know, the Polycom solution is way better. There is a company, I think it's the same company, Polycom.
This is our input. It should be turned on, right? If you're connecting the laptop with it soon.
Oh, now it's on. Green
Yeah,
lights.
yeah.
Then still.
Checking for deployment.
Oh, that's device is still not here, not yet.
Nice user interface.
Now.
Try your laptop now. Try your laptop.
Why? It didn't work there?
No.
Yeah.
Oh yeah. Oh,
And this one.
you guys have an A.
This one has. This one does. Because of the wire. Wire in the back is twisted. That's why you see.
Joma,
Yeah.
I think you need to be skinnier so that you can
Yeah, I think I can
go back behind that terminals. You're too fat to get inside.
No, there is just trying to restart the. Look, it's alive, but look the connection.
Yeah, one monitor is dead. Yeah. But anyway, at least we can continue.
You know what? Yeah.
Can you shift the screen from it, like?
Not.
No.
I don't know, right?
I mean, like.
I know what you mean. Yeah. You can see this. at least
That's it.
there.
Yeah.
Lower right.
You can wall plate.
That's what we have right now.
Oh no, you can change the look. أيوة. أيوة. 1 2 3 and that's it. 1 2 oh my god, double it.
That's okay. Yeah, put it there.
Okay.
Yeah.
Okay.
At least you can see
Yeah.
something. Yeah. By the way, what is the problem? What was the problem?
Connections.
Well, no, we didn't do anything.
Always-
I think this is a device issue, right?
No, this one sometimes overheat.
This issue or
No,
that,
no,
that issues?
one, the hub always.
Oh,
Anything with
okay.
HDMI overheat because they should attach with the disk, not in the floor. Because the dust and the heat.
But first time, since I
Okay.
gave my lecture here, I think about 4 or 5 years ago, first time, disconnected. All right, let's see if I'm still. Do I still have? Let's see. Oh, still recording. Okay. Okay, we will now practice, right? So practice. In my case, in order to practice, I need to start my MySQL. Okay, so MySQL is running. So USR local MySQL bin MySQL -u jun -p jun. All right, show databases. I am going to work on remember that last week because of a mercy u has some of the tables already defined and some conflict, so we changed it to mercy u2. So I want to use mercy u2 and show tables. I have only department and employee tables. Let's say employees. Employee has some of the sensitive columns. To know it, describe employee. Then I have salary. All right. So let's first try to do. Let's see. Select from employee. There are that many salaries already there, right? So if I want to insert into employee value, and we have to make a new employees, right? Employee is a primary key, so 201. That should be, and then name maybe Sam and what is it? EID name and department. Department, I would say 100, no, 1002. And then salary, currently there is a plain text. So if you want to encrypt it, then we use AES underscore encrypt. And then the amount that I want to put there is 106 figures. Oh, great. $100,000. And then key is, let's say, MT cyber. Okay. See what happens. Remember that if we would do MT cyber, then right now the size of this salary is only this small unit, right? If we encrypt this number, then it'll be longer. So it doesn't fit it here unless we change it. So let's first try to encrypt it. So hit enter, see what happens. If we do that, then it says error. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL. This doesn't help us, right? Right. This doesn't help. So by knowing these error messages, still you may not have any clue. But the solution is that you have to modify the size of if you see here, the type of salary is integer. Integer is only 4 bytes long or 8 bytes. If it is a long integer, 8 byte long, in general 4 bytes long. But encrypted version of salary should be very long. It doesn't fit it. Therefore, there is an error. But this guy didn't tell you that that is the reason. So reason he says here is that ridiculous reason, right? Has nothing to do with the real ones. So alter table employee and then modify attribute salary, and salary should be binary 16, which is a lot bigger than that. Alter table, we need to refer to the slide. It says alter table, modify, we have a column salary. So we have to say column. Salary, bar binary or binary, let's say binary, and 16. Yeah, it changes all others. So let's first see describe employee, and it says binary 16. It has been changed, right, from integer to binary 16, which is good. What about data itself? From employees. Is it encrypted? No, it is not encrypted yet. It is encrypted already? Strange. I didn't do that yet. Yeah, we didn't do this yet. When you do encrypt, then we need to apply this encrypt once. We do not know yet the password. Let's see what happens. Anyway, let's first try to see. It is very strange. In order to do this, cast select salary from employee, then that is it. So if you want to do AES, I think it is not encrypted, but let's try. It's very strange to me. So let's try to change it back to integer. Alt, if I change this to integer, then all of those will come back. That's what I guess. Salary. Oh, truncate salary. This is ridiculous. But anyway, of course this is from truncated. Let's do our business, okay? So if we want to do insert the way that we originally want to do, for example, new employee 102 Sam to this department, and then we have an AES encrypt $100,000 salary with the key empty cyber, and hit enter. Error. You have an error in your script. Why? Near quote. Values. No. Insert into employee. So 201 Sam 102. EID name. DEPT salary AES encrypt. Oh my gosh. What I want to do is I'm going to delete all. Okay, I want to delete. We have some tables. If I delete department, there's a primary key. So drop okay. Okay. Now I want to create table, table name employee, and then EID integer, name, text, DPT integer, and salary integer. That's how I do that. And then I want to do alt alter table, modify. Once we defined in this way, but if we want to do from the beginning at the creation step, if we want to change this to encryption, you can do that. You can put here this AES encrypt and salary. No. Yeah, here you just binary. Not, you don't need to do that. So modify column salary binary 16. So describe employee, then there's a binary, and if we put insert into employee values and EID 1001, name Sam, and department 101, and salary then AES, encrypt, and then salary is 100,000, and then the key is cyber. Or previously, I need to put one more this, because I have AES encrypt. What did I do here? Yeah, that is the reason here. Remember here, open parenthesis, and another open parenthesis, but I have only one close parenthesis. That is the reason. And do this, and then if I see select from employee, then that is the number. Okay, so it is not, that is not the same as this ones, right? This is somehow, it changed to hexa code to that size, I guess. But this is encrypted all the way here. You see here, this number is not this a simple number. This case, salary here, previously, that expanded the size only. And it has all trailing zeros. 0, 0, 0, 0, whatever that. It's not encrypted. Here it is encrypted. So I want to do, for example, without encrypt, if I want to enter 1,000 two different employee ID, and rather than Sam, Bob, department 101, salary is 10100, hit enter, and then if I want to see employees, then see, this is encrypted, right? This is not, right? Only the size expanded. So if we want to see this decrypted, then we need to do name and salary. If we want to do, then only Sam and Bob. As we can see here on this slide, if you want to see AES underscore decrypt, and then salary followed by cyber, because I put cyber here, right? Cyber is the key. This, and hit enter. Then Bob, I cannot do. Bob, I cannot do. I cannot decrypt it because it was not encrypted. But this was encrypted, therefore now decrypted. But if it is decrypted, then still I do not see this number. Therefore, what we need to do here, cast into character 16. So I need to put here cast as a character 16. Okay, and see, open and open, close and close. I need to have one more close here, and hit enter. Then I can see Bob's salary is 100,000. That is what? No. Sam's salary is 100,000. That's what we have. Bob's salary, I do not know how I can see Bob's salaries. Let's try Bob's salary in this way. Here, I wanted this to cast Bob as previously integer, right? See what happens. It's not. Then we can see character 4. Yeah, then, character 8. Then I can see the Bob's salary. Remember the Bob's salary? Where is it, Bob? Yeah, Bob. I didn't encrypt, but I put the salary 101,000, right? 101,000. Bob's salary was not encrypted. How can we get the Bob's salary? Like this, 101,000. Without encrypt, but we have to cast it because the size of Bob's salary already the same size of that encrypted versions. So we have to squeeze that to the real salaries, which is 8 byte long. That is an integer size apparently in MySQL. It depends on the DBMS. So I first tried character 4, then I have only 4 bytes long, so I put 8 bytes, therefore it is long enough. All right? So two things can be separately and independently we can display and we can store. 2 different cases means either encryption or plain text for store. Same thing, either decryption or plain text. Both needs to be casted to the character size, proper character sizes. All right? You can do this included in your Python very nicely, right? Then you can decrypt and encrypt so many columns and rows automatically. Here we try to do manually only. Question about this? If no question, then we'll do something that I prepared extra. So encryption is this, pictorially. Actually, this side is not decrypted database. This is a plain text database, left-hand side. If we do encrypt it, then it goes into decrypted database. Okay, there we need to have a key. So we put key phrase and key algorithms. Key phrase and key algorithms used in MySQL is SAR, I think 256. That is a key encryption algorithms used in MySQL. So given key phrase, in our case cyber, then SAR 256 algorithms automatically inside MySQL made it the symmetric key. And that key is used to apply the encryption algorithms. Algorithms for encryption used in, and The one that we practiced is this, AES, Advanced Encryption Standard, AES underscore encryption, okay? So now we understand how it went, right? So use these algorithms, and we enter the key phrase. Inside, there is a SAR 256 algorithms involved to generate symmetric key, and then both together to encrypt our database. Oh, and then my textbooks. But I remember that I put my textbooks, so you can read some of the textbooks if you are interested in. But I'm not going to cover all of those here in this class because that's too much. If I guide you some of those, this is the thing that we did, right? Or decrypt. This is encryption. Encryption in Pythons. There's some other, and it's more feasible if you do graphical user interface codings. So something that you can display when you have that graphical user interface. Okay, I think this is it for today. Any question? Okay. If there is no question, class is end. And then we'll meet next week. Next week, what we will do is, I think, authorizations. So how we can authorize who can do what in database.
This topic is interesting than all the topics.
So you like encryptions? All right. See you later.